Okay, in our problems in the chapter covering normal distributions, one of the things that we have to calculate, a typical problem involves figuring out the probability of something occurring given a normally distributed random variable and the value of the random variable that we're interested in. Here's an example of that sort of a problem. A radar unit is used to measure speeds of cars on a motorway. The speeds are normally distributed with a mean of 90 km per hour and a standard deviation of 10 km per hour. What is the probability that a car picked at random is traveling at more than 100 km per hour? Okay, now as I've explained in class, anytime you see something that says normal distribution, you will probably need your sketch here. And it doesn't have to be pretty. You want something that looks like that. All right, and we're told that the mean of this distribution is 90 km and the standard deviation is 10 km per hour. And the question they're asking us is, what's the probability that a car picked at random is traveling at more than 100 km per hour? Well, here's 100 on our graph, and there's the area, or there's the tail that we want to find the area of. Now, what we do is we do a calculation of x to z to p. And you remember our formula for z. We say z is equal to x minus mu divided by sigma. In this particular case, we have got 100 for our x value minus the mu, which is 90, divided by the sigma, which is 10. I don't even need a calculator to do that. 100 minus 90 is 10, divided by 10 is 1.0. Okay. So that's my z. That's the z. And to get the corresponding p, what we have to do is we have to go to our standard normal table. Now here's a standard normal table. It doesn't look exactly maybe like the one in your book, but it's close enough. It is a two-place table. That is to say the z-scores down the left column. For example, we have 0.1. Here's the second decimal place, in case you don't know. 0.10, 0.11, and so on. And we are looking for 1.00, which is 0.84134. Now, notice that in fact, our picture shows us that we're not, this is the 84% here. What we're looking for is we're looking for this piece here. And so what you have to do to get the p, the probability, is subtract 1 from 0.84134. And that'll give you the answer. Now, let me do the calculation. I'm not even going to show you the calculator. We'll just do it here. Minus 1 minus 0.84134, 15866. 0.15866. Now, I also show the students in class, and here for the record is another interesting observation, is that because our graph is symmetric, we can get the same number over here just by using the minus of the z-score. So if we go in with a z-score of minus 1.000, we will find that we get 0.15866. This is the, oops, got to show it there, minus 1.0 here, 0.15866. Hey, that's exactly what we got when we did the calculation. So you can see that's how you get the answer. And so what it says is that the probability that a car picked at random is traveling at more than 100 km per hour is about 16%. That's it. You can do this on the calculator. Calculator's nicely equipped to do this, and it's worth showing you. You go into the distributions. You hit second, and then distributions, and we're interested in the normal CDF. That's the normal cumulative distribution. We punch in there, and we get a function. There's our function here. And you need to know what the arguments are. The arguments are going to be x1, x2, mean, and standard deviation. 4 arguments. Okay. In this particular case, what we're interested in is x's between 100 and some larger number. So we put in 100, comma, and put any larger number you want. We'll just put in, let's say, 500 kilometer per hour. That's nice. Then the mean, which is 90, given, the standard deviation, which is 10, and calculate, and there's 1.15865, and that's essentially the same thing. See it? So that's how you do the calculation using the calculator. But you can always do this sort of stuff by hand, and that's what I like to make sure you know. In my classes, what I like to have you do is do it by hand and then use the calculator to check your work. Okay?